side? Excuse me. Does that give me secant of x to the n minus 2 power in 2 factors of the tangent of x? Oh, that means an invariant integral? Well, maybe not that one, but this one can be interpreted this way. I want to yes or no answer. Did you guys see that? No, I'm trying to beat the clock. I skipped a step. Technically speaking, I replaced tangent square root of x with secant square root of x minus 1. Then distribute this factor in over the subtraction operation. It's just that now I can bring this term to the other side. And I think that leaves me with a certain number of secant n x's as an integrand. How many of those are there, actually?
Can you just do that without, because the way I see it, it's trapped within the integram position without taking the integral?
It definitely is not, and let me show you why. Watch. I'll put an extra step. Let me distribute. Is that an n minus 2 times this interval? Minus an n minus 2 times this interval. And David, I did actually apply 2 steps again simultaneously. I first broke this up into the difference of 2 integrals, but I distributed that coefficient inside. Now I'm going to take this one squiggly line term and sail it to the other side. That means I have to add n minus 2 times an integral to both sides. But if I add n minus 2 of those things to one of these things, how many of them do I have left over? N minus 1 of them. Because n minus 2 plus 1 is n minus 1. Times the integral of the secant n of x dx being equal to the tangent of x secant n minus 2 of x minus n minus 2 times the integral of the secant of n minus 2 power x dx.
I'm sorry, you lost me at adding the n minus 2 secant.
But think of it this way, David, watch. N minus 2 times something.
Yes.
Plus 1 times something. And I think n minus 2 times pound symbol plus 1 times pound symbol is simply going to give me n minus 2 plus 1 times the pound symbol if I distribute it out or factor it out.
Okay.
And that's just going to leave me with an n minus 1. Oh, you guys, what does the author say? Oh, look at that. It's exactly what I have. You just finally divided both sides by n minus 1. That's where that reduction formula comes from. And so now, to answer my original question, if n is equal to 5, watch this. Plugging 5 in for n here. This gives me a secant cubed. But now with the secant cubed thing, I can apply this reduction formula again. And just slam it out in terms of the integral look at secant of x. But you and I know the integral of secant of x is natural log of the absolute value of the sum of secant and tangent. Do we not? Guys, give me some feedback. I need to know where you're at. Yes, sir.
I'm confused about the tan squared x on the
Yes.
first line. What happened to that?
I did this. Now watch. With my green pen, so you can see I'm changing things. I just rewrote tangent squared of x as secant squared of x minus 1 using my second Pythagorean identity. And then simultaneously, I distribute this multiplication over the subtraction. And that's where these two terms come from. Yeah, just bug me. Just bug me. Guys, I seriously need some feedback. I don't know where you guys are at today. Is this just boring you to death? You want to go to sleep? When I think about it, or is this really tough? Really?
I'll tell you tomorrow.
Oh, okay. You know what? I wasn't expecting that because you were so quiet. Sir.
Yeah, I don't really understand the second last step of we got like a bunch of n minus 2.
You mean from here to here?
Yeah.
Okay, watch this. Green pen. So far, so good. I didn't do a lot. I just split the one integral into the difference of 2 of them. But now to remove the green brackets, don't I have to distribute this to this first integral? Oh, look at that. I just did. And multiply the second integral. Look at that. I just did.
Plus n
guys, he's right. I made a mistake. I didn't mean to make that mistake. That really is my blunder. I got a sign error in here. S-I-G, not S-A-N-E. And distributing as negative coefficient, that makes this one positive. Thank you very much. I really didn't see that. Come on, any other tax? I'm open for tax. What's that? Actually, it doesn't. I just changed the last sign. That's the only thing it changes. And Linda, to get what the book has, I hope, in fact, we better double check, just make sure I didn't make any other mistakes. Dividing both sides by n minus 1. I'm serious, you guys, I want an answer. Does that match up with the authors? I can't even read this. Secant n minus 2, tangent n minus 1. Yep, you guys fixed my sign error. Now I got exactly what he has. Good. I'm happy. Sorry, you're not happy.
Do we have to know all of them?
Take a little cheat sheet of this.
Yeah, a little, maybe,
I don't expect you to know any of them.
no,
No, but you know what? I could ask a question I haven't asked. Prove it. Prove the reduction formula. I'm just not a formula-driven person. I don't care if you guys do the formula. Well, let's see what I can dig up for some practice. Wow, we're in a bold new chapter. And you yawn.
Is there going to be any extra credit questions on the test tomorrow?
Extra credit questions?
Yeah.
What's that?
I'll try to think of one.
Okay.
I'll consider it.
Cool.
Quiet. So you guys gonna make sure you're gonna get this done tomorrow?
No.
No, it's not an exam. You don't have to get it done for tomorrow. If you want to keep it for the weekend, that's fine. Let me know how it goes. You guys, I promise, before I leave this room, I'll post the solution at practice class. I should have done that before.